Hey guys, for number 3, we are going to continue. It's really a continuation of number 2. So number 2, we calculated, right, the entropy change of the system or the reaction for these 3 equations. All right, now we're going to calculate the surroundings. And for the surroundings, we need delta H, right? So for our equation, delta S of the surroundings will equal negative delta H of the system all over the temperature in Kelvin. All right, and so let's start with this. I've already looked up in the same spot where you look up delta or S. I looked up the delta H values for these substances. So for A, right, delta H, how do you calculate delta H of the system? Well, that would be the sum of the delta H of the products minus the sum delta H of standard reactants. All right, so for A, we have products SO2, and again, there's only one of them, minus reactants of S rhombic, and O2. So SO2, sulfur dioxide, is negative 298.6, and it's kilojoules per mole. And these are 0. So for A, delta H standard of the system is negative 298.6 kilojoules per mole. So now delta S of the surroundings is equal to, now we're at 25 degrees Celsius, but it's equal to negative delta H over the temperature. All right. And so delta H is, of course, we'd have, it's a negative 298.6 kilojoules per mole. And the temperature is we don't want to do that, 298 K. So that means our surroundings for A would be, what, 0.996? That would be in kilojoules per mole Kelvin. Or if we make it joules, 996, really, joules per mole Kelvin. So now, determining if it's spontaneous. All right, how are we going to do that? Well, that one, we got, oh, I don't want this, I want this. Delta S universe equals the system and the surroundings. And so if we have the universe here, equals our system and our surroundings. Well, our system is 10.9 joules per mole Kelvin. Actually, yeah, is 10.9 plus, we have 996 joules per mole Kelvin. So that means our delta S universe equals, I don't know, 1,007 about. And because it is positive or greater than 0, we are spontaneous. All right, so that's A. Same thing happens with B now. For B, and I'm just going to go right into it. We have products, magnesium oxide and carbon dioxide minus our reactant, magnesium carbonate. So magnesium oxide was negative 601.6. And these are all in kilojoules per mole. And CO2 is negative 393.5. And magnesium carbonate is negative 1,095.8. And so I get a positive number. Yep, positive number, 100.7. So I get 100.7. All right, so now we have to do delta S surroundings. And again, that equals negative delta H system over the temperature, which our system is what? 100.7 kilojoules per mole. Temperature is 298. That looks like our surroundings would be negative 338 joules per mole Kelvin. And then we're going to do the delta S universe again. Our system plus our surroundings. So our system from part A, if we scroll up, is 175.1. All right, so I got 175.1 joules per Kelvin, or mole Kelvin, Kelvin mole. And the surroundings are negative 338 joules per mole Kelvin. And so if we do that, you got your 175.1 minus your 338. I get negative 162.9. So negative 163 joules per mole Kelvin. That would be negative, so I'd say it's non-spontaneous. Non-spontaneous. And then we got C. C. So for C, delta H of the system is equal to what? We would have 4 CO2, 6 waters, 2 ethylene, and 7 oxygen. All right, so 4 times carbon dioxide was negative 393.5. These are all kilojoules per mole. Water was negative 285.8. Two times ethylene, which is negative 84. And 7 times 0. All right, so for delta H is equal to, if we do this all out, I think we get negative 3,121 kilojoules per mole. All right. And so, back to delta S surroundings is equal to negative delta H over T. And so we have negative 3,121 kilojoules per mole, 298 Kelvin. And so for, I'm getting 10,500, or 1.05 times 10 to the 4th joules per Kelvin mole. So I converted on you. Technically, you get 10.5 kilojoules per mole. All right, finally, delta S universe. We have our system and our surroundings. So our universe will be our system, which was, if we scroll back up, negative 619.6. And then we're going to add 1.05 times 10 to the 4th joules per mole Kelvin. So for my universe calculation here, what I'm getting is 9.9 times 10 to the 3rd joules per mole Kelvin, which is positive, so I would get spontaneous. All right, so that is how you would do 3 in conjunction with 2. All right, if you have any questions, feel free to reach out. Otherwise, we'll see you next time, guys.